morning, everyone. We're going to give it a couple more minutes for people to sign on. We can tell there's still a fair amount of attendees coming on right now. So just give it 2 more minutes and then we'll get started. Those of you just coming on right now, we're going to give it about 1 more minute before we start, just to let a few more people log into the webinar. Okay, why don't we get started? Do a quick introduction here. My name is Matthew. I'm the CEO of Fraisa USA. I'm in Fraisa USA's Tool Lab currently. I have with me Doug, who is our lead applications engineer, and he will be helping me along with today's webinar. And I also have with us today Courtney, and Courtney is the one that set this webinar up for us. She's also going to be able to, if you want to use the raise your hand function or put a question in the chat, feel free to do that. Courtney will be checking that to make sure that we can answer any questions that you might have. I'm not sure if everybody's aware of how to use GoToWebinar, but every screen that you see, you should be able to adjust the size. So when we get into the presentation or videos or going through the online calculators, feel free to expand those windows and make the windows of our video feed a little bit smaller. So first thing I'm going to do here is talk a little bit about the idea behind Fraisa's ToolExpert, our online calculators. So Fraisa has spent a lot of time and energy trying to get good, solid speeds and feeds for cutting tools. So what Fraisa's always tried to do is give you one particular set of parameters that works for a material type, and that way it takes a lot of the guesswork out. Now, when we looked at what's available out in the market, a lot of our competitors, their data is very confusing. If you look at the chart here on the right, I won't tell you who it is, but half of you probably already can tell. You have to do a lot of math to find the parameters. They give you ranges for cutting speeds that are pretty broad, 120 to 180 surface footage, certain number times D. You know, there's a lot of math to do to figure out the parameters. How am I supposed to use this solid carbide end mill? Also, most competitors, they derive their speeds and feeds from one set of data, and then they extrapolate that mathematically over different sizes, different material groups. That is a fast way of getting cutting data, but it's not a very secure way. Another reason why Fraisa focuses on this, because our industry is changing. We're losing a lot of experienced talent. The older people in our industry are retiring, and what happens is we lose a lot of productivity because of the know-how, what speeds and feeds I'm used to running my particular tools at. Also, new programmers don't really get the same ground-up experience anymore, so people could be coming straight out of a trade school not really have done a lot of machining, but getting into a programming job. And that's a problem because they don't have that experience, the sound, the feel for it, making chips and understanding how the speeds and feeds work. Another thing that's big on our agenda is the safety and automation. So we want to be able to give our customers a parameter that works right out of the gate that's safe. Obviously, you can always dial things in, make it a little bit better, cut a little bit faster, but we want something that works out of the gate. We know that personnel costs are extremely high, so we have to use our people better. That means automation as well. So you don't want to have to test every single tool to get the right speeds and feeds. And really, what we think is what you've planned for should just work. And that's what we're trying to get our customers. Fraisa focuses a lot on research and development. We have a tool school in Europe and a tool lab here. These are areas where we do a lot of testing in a lot of different material types to derive our speeds and feeds. So we have 9 CNC milling machines that we use strictly for testing and training. That's a huge amount compared to most solid carbide round tool manufacturers. 7% of the revenue that we earn goes straight back into research and development. That's about double of any one of our competitors out there. So most competitors are in the 2 to 3% range. We're putting 7% back into R&D, and we come with a constant wave of innovation and products in our innovation in our products and in our software. And that brings us to the ToolExpert. So on our website, to get to our ToolExpert, we just click on Online Tools. So what I'm going to do now is have Doug explain one of the parts that we're going to show you that we've machined, show you the part, describe the strategy that he wants to program that part, and then we'll go through the ToolExpert and get the speeds and feeds.
Okay, so this first part here we made out of D2 tool steel, heat treated to 60 Rockwell. This is done in hypermill, so all of the dynamic milling and all of that is that's a volume mill add-on within their software. And the first operation that we chose was with our HX NVS, and that was a 3/8 tool just to get the bulk of the material out as quick as possible. And then you start getting some of these small fillets down in here, so we decided to drop down into a 6mm HXR NVS. That's the same series of tool, just with a corner radius. So we go from a volume mill type cut to then a volume mill bottom up roughing type cut to get the rough shape in with that 6mm tool. Then after that, we switch over to a high feed style cut. You'll see with all of the tools we're going to show that we like to use them for multiple applications. So this tool is doing standard volume mill or dynamic milling, and then it's switching to high feed cutting. And then once we get to that, we actually switched over to a pre-finish pass to get everything very close to near net shape, so that then we can come in with a small ball nose and finish the entire part on that. So I'll switch back over to Matthew. And he can go through the ToolExpert portion of it for getting the parameters.
Thanks, Doug. Okay, so again, online tools. The primary ToolExpert that we use is going to be our ToolExpert standard, but we do have specific ToolExperts which we will show that are really dedicated to one series of tool. But we're going to start with a ToolExpert standard. Doug said he wanted to use a 3/8 inch tool, so we're going to stay in imperial sizes. And I'm going to choose the ToolExpert tool choice, which is going to give me the opportunity to start with the material that I want to machine. And in this case, Doug said this is D2, 60 Rockwell. So I'm going to pick this from the simplified material selection. I'm going to pick the 56 to 60 Rockwell range. I'll show you later on how we can search for different materials, but for this first one, we're going to pick the simplified material. So Doug wants to do some dynamic milling. We call this high dynamic cutting. And in this hard of a material, we offer just high dynamic cutting for speed. That's going to be your 2.5 to 10% step over. Performance typically ends up being 15 to 25% step over. So we'll go ahead and choose this. We want to choose a 3/8 tool. And here we get our choices of these two different tools. So we're going to pick the version with a clamping flat here. And now we come to our parameters. So depending on how Doug wanted to program this, we could have done a 5%, 7.5%, or 10% step over. And you see here the material removal rate doesn't change. What happens is our step over changes. Then we can increase or decrease our cutting speed, change our chip load based off of chip thinning, which then changes our feed rate. So no matter which step over we take, we're getting more or less a constant material removal rate. So at this point, then we can see this tool. So now if I had another application for this particular tool, I would add another application right here. Otherwise, I can add a new application, which then brings me back to the ToolExpert, the home page of the ToolExpert. So now Doug said he wanted to do a 6mm tool. So what we're going to do is, again, this time we're going to click on Expert, choose the 56 to 60 Rockwell range. We still want to do high dynamic cutting with a 6mm tool. And here we have our choices of 6mm tools. Now, Doug programmed one with a 1.5mm corner radius. So you can see here we can start to narrow down all of the different features of the tool. So if we want to look at corner radius here, we can go to 1.5mm. Here's the choices of tools that we have with a 1.5mm. So we'll pick this first one and go forward. And now we have our speeds and feeds for this tool. Again, we could choose from one of the preset step overs, or if we really wanted to, we could modify our step over and put whatever we wanted, and we would get a new speed and feed for that. So let's take a look at this tool. Okay, now we want to use the same tool. So we're going to choose another application. And in this particular case, we're going to go to the 3D machining applications with this mold, and we want to use high feed cutting with the same tool. So here are our high feed cutting parameters for this tool. And again, you can toggle the speeds and feeds in inch and metric, whatever you prefer. I realized I didn't show my screen that last go around. Sorry about that. But I will add another application here. We're going to pre-finish with the same exact tool. So add another application. Again, get into the 3D machining applications where just before I picked high feed cutting. Now I'm going to get into pre-finishing with this same tool. Once I hit on pre-finishing, we have a working angle here. That's basically what you want to program for, which is going to give you the best performance based off of the diameter or effective diameter of your tool. So in this case, we're doing a 20-degree working angle. That's the slope of the part. And you see here our new effective diameter is no longer a 6mm corner radius tool. It is a 5.32, and that's how we derive the RPM based off of this cutting speed. So let's take a look at this video. So all of the things that we did with this same exact tool, we have all of these PDF setup sheets right here, so we can download those. And then you can utilize these setup sheets to program off of. So we have all of the pertinent information about the tool up top, which material you selected, what the application type is, and of course the speeds and feeds. And we just go throughout all of the different applications that we went through. So let's take a look at a second part.
Okay, so this part here we did in Mastercam. We made it out of P20 mold steel, and we used the MFC-R tool. And here again, it's a tool that's designed to do numerous operations rather than just dynamic milling or just a high feed tool. It does a little bit of all of that. So we start off, because all of these surfaces are tapered or curved, with Mastercam's OptiRough path. So it's a dynamic milling in and then bottom up roughing to the top. Then we switch over to a high feed type cut, because this is a very flat, low or high curvature surface at the top of it. So we're high feeding around the top of it to remove that material type, or material, I mean. Same thing for the lower portion, because it has that same curvature down here. And then we switch over, just like with the HX RNVS, to a pre-finishing or more of a finishing type cut to surface machine all of these 3D surfaces on this part.
All right, thanks, Doug. So Doug wants to use the MFC tool. So what we're going to do is choose the ToolExpert MFC. So again, this is a dedicated ToolExpert just for the series of tools that we call multifunctional cutting. So these MFC tools have their own ToolExpert. Now, if I already had a tool in hand, I could pick this area here, which is really just getting the cutting data for the tool I have in hand. Otherwise, if I'm searching for the right tool for my application, I'll do that here. So Doug said we're machining P20. So again, we have this simplified material. P20 is probably in the range of, I don't know, 28 to 30 Rockwell. So we're going to pick this 24 to 34 Rockwell range, go forward. And now we have all of the different applications that we want to be able to do with this particular tool. So I want to use some high dynamic cutting. Again, high dynamic cutting for speed is going to be for your lighter, faster machines. That's going to be anywhere from a 2.5% step over on up to a 10% step over. High dynamic cutting for performance, that's going to be for a little bit slower machine, maybe a machine that doesn't have high speed look ahead, a bigger, more robust machine. Now you're looking at 15 all the way up to 25% step over. So if I pick high dynamic cutting for speed here, we know we want to use the MFC with the corner radius. And Doug selected a 3/8 tool with a 60 thou rad. And here we get our parameters. Again, 5%, 7.5%, 10%. And take a look at the feed rate, because if you're not reaching a feed rate of 540 inches per minute at a 5% step over, if you don't reach that 80% of the time, then you should probably go to a lower step over. So you see, if we went from 5 to 7.5%, our metal removal rate stays the same, but our feed rate dropped to 360. If the machine wasn't hitting that 80% of the time, then we would drop it even further to 10%, which is 271. So the key factor there, just make sure that it is giving you the 80% of the time reaching that actual programmed feed rate. So we got our speeds and feeds here. Let's take a look at this tool in action. So now we're going to continue to utilize this tool, and we just want to add another application to this tool. So you saw before at the very end of that video that we had our helical ramping here. We didn't actually show the speeds and feeds for that, but it's pretty simple, and it'll show you exactly how to do that. The next video that we have for you is roughing in a high-speed cutting way, so light axial and radial depths of cut. And we see here that we have a surface speed of 627 inches a minute, so 6,570 RPM, 72 inches a minute. That is our parameters for this high-speed cutting. Okay, now we can utilize the same exact tool for another application, and we want to get into some pre-finishing with this tool to utilize that big corner radius. So if we have a different set angle, we can change that. If we think we're going to be at mostly 45 degrees, we can keep it at 45 degrees. In this case, maybe we're closer to 55-degree working angle, so that then changes our speeds and feeds. Now, if you didn't have a machine that had 10,000 RPM, for example, you can always change that RPM with the modified cutting data parameters, and that's going to give you a new feed rate. Let's take a look at this tool doing the pre-finishing. So again, we have all of our PDF sheets, our setup sheets saved right here, so we can download those. And the great thing about the ToolExpert software is that we give recommendations, application recommendations for coolant as well. So in this particular case, we're saying you could utilize either wet machining or dry machining, and you can utilize this tool with the coolant hole straight through along with the side coolant. If we're going into deep holes, circle interpolating into deep holes, we're going to have people shut off the side coolant so that only the coolant in the middle is blowing those chips out. So pretty easy to follow those application recommendations. Why don't we swing it back to Doug and go to the next part here.
All right, so the next part here is a larger part that we made out of aluminum, 7050 aluminum. And we initially started off by roughing it with a long square tool to get bulk of the material out of there. Then we actually switched over to our new Sphero Alu ball nose tool. And just like the last two tools, it's very versatile in what it can do. So we started off with actually a true volume mill type path, bottom up roughing, coming through this center slot here, and then working its way up and out. And then the other application that we will show will be like a pre-finishing type pass to come in and just knock the extra material off around all these corners and bring these tapered surfaces into size.
Okay, so now I'm back at the ToolExpert standard, and Doug has given me the part number that he wants to use, so our tool number. And so I'm going to go ahead and just put that tool in here, 7550-300. We see we have one choice. So this is the tool that Doug has selected. And now we could pick from the simplified working materials, but in this case, if we wanted to search for our specific material, because we do give different parameters for 6,000 series aluminum versus 7,000 series. So I'm gonna go ahead and search for 7050, and here we see the USA term for this particular aluminum, 7050. So we'll select that. And now with this tool, since we're in aluminum, we can use high dynamic cutting in a performance. That means a larger step over. And we can either choose 15%, 20%, or 25% step over. In this case, we're choosing a 15% step over. And let's take a look at this tool in action. Okay, so now we want to utilize the same tool in a different application. So we're going to add an application here, and we'll get into the 3D applications. And what we wanted to do is some high-speed cutting in a roughing way. And we see here that with these speeds and feeds, we're working at this specific effective diameter. That's how we got our RPM. Again, if we didn't have 24,000 RPM, we could change this to 18,000, and we would get a new feed rate based off of that RPM. Okay, and again, our PDF setup sheets are right here waiting for us. So why don't we take a look at the last part, Doug, if you can bring us through that.
Okay. So this part here is another aluminum part, except in the 6061 aluminum that we did. And we chose to run this one all with our conical barrel tool that we call our R-Cut X. You'll see that it's a relatively deep pockets with small corner radii. So in order to finish that, you'd be a smaller tool sticking out quite a ways. So that's where the R-Cut really benefits. But first operation is with a 12 millimeter AX FPS aluminum rougher. You'll see that it can helical bore in very heavy into the material, and then it takes a full 80% step over to actually rough through that material, and it doesn't need a dynamic cut at that point. And then the next tool is just switching straight over into the R-Cut tool. Turn that on. So that's the shape of the R-Cut tool with the cutting, with the cutting edges being at the lower portion and the end of the tool being a true ball nose. We can work in these fillets using the ball end of that tool to get that extra material out of there. And then you'll see the more horizontal paths stepping down the part, where if this were like a curved surface or things like that, and you're normally using a ball nose, these step downs would be much larger than what you'd use on a ball nose. So that's really where these tools shine, plus in pockets that are very deep that you'd have to use a very small tool. We can really choke up on this tool and get the holder all the way down into the part for more rigidity. Okay.
All right, so Doug wants to use our AX FPS roughing tool. So what I'm going to do is go back to the online tools, pick the ToolExpert specific for AX FPS. And the interesting thing about this ToolExpert is it's really dedicated to the machine that you're going to be utilizing it on. So I'm going to pick the tool available. I know which tool we're using. This is the tool I have in my hand. It's a 12 millimeter tool, a long version. We'll go to next. Again, like I said, we have 7,000 series aluminums, 6,000 series, or even cast aluminum, so different parameters for that. We're going to pick 6,000 series aluminum here, and we're going to get into high performance cutting. So like Doug said, an 80% step over. Now, the great thing is we have the opportunity for you to customize the speeds and feeds based off of your machine. So if you don't know the power torque diagram of your machine, then you could ignore the spindle. Obviously, you're going to know your internal pressure, whether you have good coolant or not, the taper of your spindle, the gauge length of your tool. All of that is going to help customize the speeds and feeds for you. Once you do it one time, then you can actually load it. So I'm going to load it for my Hermela C22 that we have in house. And now I get my 18,000 RPM, the 17 kilowatt max, and the bending point at 3,000 RPM. So that's going to customize my speeds and feeds. What that does too is it's going to tell you whether or not these speeds and feeds are an overload on either the tool, the spindle, or the machine environment. The machine environment has a lot more to do with the coolant or the taper, for example. So here are my new speeds and feeds for this tool. And why don't we go ahead and watch this guy running. Okay, so next thing is going to our conical barrel tools. That's what we call R-Cut. So we're back to our online tools. We're going to go to the Fraisa ToolExpert for R-Cut X. We can open that up. And Doug has told me which tool we want to use. Now, we have a choice with or without coating. For aluminum, we're going to pick without coating, and that's going to give us those tools. And then this is the particular shape of tool that Doug was utilizing to program with. So you can see here, we have the tool in that shape that was the same as his program. Now we can utilize our aluminum alloy, integral aluminum, cast aluminum. And here, we're going to go from the wall finishing to the radius finishing. And so if we just pick one, then we can get our speeds and feeds for the wall finishing. And you can see here that we have a certain contact point. Some softwares, when you're programming these conical barrels, will allow you to change that. So you can choose whether you're at the tip of the tool or up on the very side of the tool. That's going to change the speeds and feeds. And then we would add a new application for that tool, finishing these fillets. Here's our new speed and feed. Again, we don't have 45,000 RPM, so we need to drop that down to our max, which is 18,000 RPM. Now we have a new feed rate. And we have both of those setup sheets available there. Not only the setup sheets, we also have simulation files, we have DXF files. All of this information is in the ToolExperts so that you can bring that directly into your software. Currently, we also have an XML for Hypermill, so you could import all of this cutting data directly into Hypermill. We're also working with Mastercam and a couple of other CAM companies to try to get integrated into the CAM system, which will just help that programming or that programmer save a lot of time. So let's take a look at the barrel tool in action. So a ton of information that we've given you, of course. It's a lot more than probably what you can take in all at once. Obviously, we've recorded this so that you're able to watch it again. But what I will say is that you're not an expert with the ToolExpert the first time that you use it. Obviously, the Fraisa salespeople are more than happy to go through this. Doug and I do this on a daily basis to go through with people via Zoom calls, for example. So we can step through an application that you might have, show you exactly how we would get the speeds and feeds. Once you've done it once or twice, it really is pretty easy and intuitive, but the first couple of times maybe you might want us to guide you through. So just a couple of things to discuss. You know, Fraisa has spent a lot of time in the R&D department getting these speeds and feeds. Every video that you saw, the speeds and feeds came directly from these ToolExperts, and you could hear and see the cut. It's really a safe and good way. And the other nice thing is if we come with a new tool, a new feature, a new application for a tool, or maybe we had a tool that didn't perform exactly like we thought it would, or we have some customer feedback that says maybe you could increase the surface footage or increase the feed rate. That's all live updates. So because the ToolExpert is on our website, you can be for sure that you're getting the most up-to-date information. Doug, do you have anything to say? If we're open to any questions that you might have, otherwise we'll answer any questions via email.
Yeah, the only thing that I would mention I use this all on a daily basis. You know, the ToolExpert standard is definitely the main one. The AXFPS one and the RCut tools, those are not in the ToolExpert standard because they have they're more specialized. So we chose to give them their own individual calculators. but everything else is going to be in there, including our drills and indexables also. And going through it, every once in a while, you'll come to a sort of, I don't know, maybe a dead end or an application that you want to do, and it says the tool doesn't have it or something like that. And that comes back to the fact that everything we put in here is tested. So there might be an application or a case where we haven't tested it and we don't feel confident in just throwing in parameters and guessing at them just to have parameters available. We want to really make sure that what is in there is accurate and will work for you. So if you come across those types of things, just let us know. You know, if it's a tool that you're using a lot in a certain way, we can request that type of application get added in to this. It is a sort of, you know, living, breathing software. It gets updated quite frequently. Anytime, like Matt said, you know, anytime something comes up, we can change that and have it updated.
So Doug, it looks like we have a couple of questions here. We got the first question is, do these tools work with CATIA, which
are we referring to barrel tools or?
I'm assuming because otherwise, I mean, everything works in CATIA. So
everything else would work in CATIA. So I'm going to assume the barrel tools. I actually don't know on that answer. That's one software that we haven't really worked closely with. I know they work in Mastercam, Esprit, Hypermill, Gibbs. So my assumption would be that yes, they will. In a lot of cases, if they don't have these tools as a truly defined, either they call them a conical barrel or a circle segment tool, or they have a bunch of names for them. If they don't have them defined as that within the software, then you'll have to bring it in as the DXF model and define the cutting portion, and then you just use the tilts, you know, the tilt angles in your 5-axis process to run them properly. So that's how we had to do it in some other softwares before they added them in as a truly defined tool to where the software understood where it needed to cut.
And I think we can do a little research on that and find the answer. And of course, once we get a hold of CATIA, we can help them if they don't have that already. We can help them get that set up in their software. So second question is about retool, the grinding and coating. Is it all done in the U.S.? Yeah. So we are we're just north of Minneapolis. We do the production of a fair amount of our inch-size tools here, but we do, I would say 95% of all the special tools that we produce are in-house here in Minnesota, as well as all the regrinding. So we're utilizing really the same machines that we use for making new tools. We're utilizing those for regrinding as well. So yeah, that's all here in the U.S. Do you recommend through spindle air blast? I'll tell you that there are a lot of cases where the through spindle air blast works very well with the MFC tools, but as you get larger and larger diameter tools, your hole gets bigger and bigger, and the pressure seems to lag a little bit. So depending on how much pressure you have in your air that goes through your machine, you might be better off whenever you're doing circle interpolation to open up holes or get pockets open. You might be better off turning on the coolant rather than utilizing the air blast. And I'll tell you, 10, 15 years ago, we used to talk about thermal shock a lot more with coatings. A lot of the coatings that we have now could be run wet or dry in most applications. So that's not as big of a worry. But of course, if you have questions about that, just let us know. We'll tell you which materials you're not going to be able to run wet or dry. And actually, that's a question number 4, something about being run wet or dry. So again,
do you want to pull back up the ToolExpert and show the coolant icons?
Yeah, I certainly can. I think it's gonna make a big difference though when you're looking at what type of
Sure,
material?
yeah. So basically every application, every tool type, depending on what you're doing, there'll be the icon kind of showing the direction of coolant and where we want it coming out. And then right next to it, there'll be an icon with like a water drop shape or an air or a water drop shape with a line through it, meaning like air blast. In some applications, we recommend oil, very few, but there is an icon for every application for what we really recommend for cooling if possible. And like Matt said, though, depending on what you're doing, if it's a mild steel or something like that, it can be ran with coolant or with air. And the through coolant thing, in my opinion, whatever you have whatever's stronger coming out of the tool is going to be better. So if your air blast isn't all that great and your coolant through is much stronger, that's the way I would go.
So we have another question here. I see you provide special tooling. What's the typical lead time or turnaround? So the special tools that we provide from in-house here, our lead time is typically 3 to 4 weeks. If it's an uncoated tool, it might be a little bit shorter. 3 to 4 weeks from the time that we get the signed print from the customer. What we like to do with our special tools is give an immediate, as fast as we possibly can, give an idea of the price and the turnaround. And then our engineers really work deeper with the customer to figure out how to make the tool for their specific needs. So, of course, depends a little bit on how much work we have in our shop at any given time. There are a lot of cases where we've done it in as short as 1 to 2 weeks, but typically the 3 to 4 week range is what we like to offer. So,
If someone raised their hand,
somebody raised their hand.
do you want to unmute him?
I just unmuted him. It is a Jorge de Leon, if you're still there.
No, I guess not. Well, again, if you have any other questions, Courtney, which email would you like people to send it to, or is it on this webinar already?
I sent a message to everyone saying I was going to send an email with the YouTube link for this recording of the webinar. I will include Doug's email address in there for any questions.
Tech support at fraisausa.com. Sure.
Yeah.
Good. Well, from our side, thank you very much for your time. Hopefully this was interesting. Like I said, feel free to contact us. We can walk through your first or second application with you to make sure you get the right speeds and feeds. And hopefully you'll be able to utilize this software and be successful with it. So thank you and have a great day.
Thank you.